Hi everybody, this is Peter Lum with Enphase's Training and Education Department, and I'm here at our Fremont Training Labs, and we're going to be talking about commissioning Enphase systems using the Enphase Installer App. To commission Enphase systems, you'll need the very latest Enphase Installer App, which I've loaded on my phone. I'll go ahead and tap that to access it. I'll go to Settings to make sure I have all the proper settings so I'm ready to commission. I'll check that I'm actually logged in as a user for my company so I can see the systems that I will be working with. I'll look for the latest software to make sure that I'm up to date. In this case, my Envoy software and grid profiles both show up to date. And lastly, I'll just go down and check the version of Installer App I have, which is 3.24.0, to ensure that this is the latest version available from my local app store. Once I've verified all of these, I'm ready to start commissioning my systems. Now that we're ready to commission a system and I've opened my Installer App, I want to go to the Systems area of the Installer App, pull down to refresh the list of systems that our company is working on. Now, if our company has created the system ahead of time, which is our recommended best practice, then I should be able to find the system in my list. Our system is called the Training System 1, so I will go ahead and search for this. Once I found the system that I'm commissioning, I want to go in and check the system details, quickly scanning through to make sure that all of the information is correct. If it is, we can go back and continue on. If your company hasn't created an activation for you to access, you won't be able to find it in the list, and so you'll have to create your own. We'll do this by tapping the plus sign back in the Systems tab, and we'll start adding information. So we'll start with the system details. And we'll go ahead and save all of this with the system created successfully. So our system is now called Training System 2, if that's the system that we will be operating on. And now we're ready to continue to step 2. In this section, we're going to define the devices and arrays that are going to be in the system. We'll tap on this section to define the devices and arrays. In this case, we are going to add 1 Envoy, 10 microinverters, 3 Encharge batteries, and 1 Enpower system controller. And I'll go ahead and click Done. There's a pop-up that asks us to verify that the DC disconnect switches are turned off on all our Encharge batteries. Verify that the switches are turned off. The Installer Toolkit app will tell us when to turn them on. Another pop-up reminds us that in order to complete the commissioning process, we have to be Ensemble Enphase Storage certified and have both a cell modem and communications kit installed. After telling the Installer app the quantities of hardware installed at a given site, we'll have to scan the serial numbers of each of those devices. Starting with the Envoy, we'll go ahead and access the Envoy, tap Scan, and use the camera to scan in the barcode. I'll go to the combiner box, which has the Envoy serial number, and I'll go ahead and scan this in. I've got my serial number in, go ahead and click Done. And then I'll select my grid profile. In this case, I have a default, go ahead and use that. And next, I'll move on to the microinverters. Tap microinverters, and in this case, I'm going to use the auto function that'll allow me to scan one serial number and move on to the next. And I have my serial numbers on a sheet, and auto function will allow me to scan one, to the next, to the next, and so forth. Until I'm completed, and then I'll go to proceed to create an array. To create an array map on your phone and in the app, tap the Array section, tap Array Builder, click the blue plus sign on the bottom right, define your array name. We'll call ours Array 1, and then define how many rows and columns. In this case, we have 10 microinverters. That will be 2 rows and 5 columns. Define whether or not it's in portrait or landscape. In this case, it will be portrait. And then we can define an azimuth and tilt. We'll just leave it at default for right now, 180 with a tilt of, let's call it 15 degrees. Then we'll click Done and Add, and it will create an array structure for us that we can map our inverters to. To save your work, press the blue Save button, and then you can exit. Once we've created an array structure, then what we should do is go and assign serial numbers of what we've scanned in into their specific positions. So to do this, I'll go to Array Builder, I'll tap on the specific module, and it will give me a list of microinverters that I've scanned in. I'll choose the appropriate serial number and assign it to that location, and I'll do that with every one of my microinverters. And I'll do this until all of them are complete. When I'm completed, press the Save button to save my work, and then I can exit. Now we've scanned the microinverters and that's completed. Now we want to go to each of the Encharge batteries and scan those serial numbers. Tap Encharge and scan my first serial number. Move to the next one. And the remaining one. And now I'm done. And I'll move on to the next device. So remaining is the scanning of the Enpower Smart Switch serial number. So we'll go ahead and open this up. The serial number is located on the door. Tap Done. The Installer app asks you to specify if the site is a partial home backup or a whole home backup. It's a partial home backup in our configuration. Now specify where the consumption CTs are placed. At this site, they are located between the utility meter and the main service panel. So we'll select that and then tap Save. There's a pop-up that asks if we're backing up any large motor loads. Let's say yes. A pop-up suggests that we use a soft starter to reduce starting or peak surge demands. We'll tap OK after reading this. We're done adding devices and specifying the serial numbers, so let's tap the arrow on the upper left to return to the main menu steps. The next step in commissioning is taking the system out of manual override so we can continue to commission. To do this, we'll have to access the manual override switch that's behind the dead front of Enpower. We'll remove this. The override switch is located right here on the MID relay. The switch is currently in the override position to the left. To take it out of override, we will move it from the left to the right to disable the override. Remember, this must be done with the system de-energized and never energized. If the system has been energized, before you disable the override, you must de-energize it in a specific process. The Installer app walks you through the specific process of turning breakers off to disable the override and then turning breakers back on after you've taken it out of manual override. If the system is energized, and we need to disable manual override, we'll have to de-energize the system first by turning off the main breaker, which feeds Enpower, and then within Enpower, turn off Encharge breaker, AC combiner breaker, the neutral forming transformer breaker, and the Envoy breaker if equipped. If you have a load breaker, we want to turn this off as well. And then for each of the batteries, we'll turn off the DC disconnect switches if those have been turned on. At that point, we can then move the override switch from override position to disable manual override from the left to the right. After we've disabled manual override, we can go back turning the Encharge breaker on, AC combiner breaker on, NFT breaker on, the Envoy breaker if equipped, the main load breaker, and then the main AC disconnect, which feeds power to Enpower. And once we apply AC power to Enpower, it will go through a self-test routine, and then it will wait for the reconnect timer before closing the MID to pass power all the way through Enpower to feed the loads. This reconnect timer can be anywhere from 30 seconds to 5 minutes, depending on the local jurisdiction and grid requirements for reconnect. In this case, our reconnect timer was based on California Rule 21, which is a 15-second timer. So after the self-test, the reconnect timer, we got power through Enpower, now feeding loads. To configure the Envoy, select Envoy Connectivity. On the Envoy, press the AP Mode button. Navigate to your smartphone's Wi-Fi settings and select the Envoy network connection. The Envoy should be Envoy plus its serial number. Return to the Installer app. Connected should show after a moment. If not, pull down to refresh. If available, complete any Envoy software updates. After an update, you'll likely need to go back to your phone's Wi-Fi settings and select the Envoy network again. The Wi-Fi network is called Enphase Wi-Fi, so I've gone ahead and selected that from my list of Wi-Fis that's available to me. And then I'm going to input the password for that customer's Wi-Fi, or I'll have the customer input that for me. For sites that use Ethernet, you'll tap Skip Wi-Fi. And then I will simply tap Connect. Now that we have a network connection, we want to provision our devices into the Envoy. To do this, we'll tap the Start Provisioning button, and that will program the Envoy using information that's captured in my Installer app. There's a pop-up that asks whether or not I want to use Bluetooth, and I want to enable that because Bluetooth is the way that the phone will connect to all of the devices to program them. And we'll see that the devices will begin provisioning, starting from the grid profile being updated, the tariff information being updated, the microinverters are being programmed into the Envoy from the phone, and when that's completed, it will read provisioned. Right, now that all of the devices are actually programmed into the Envoy from the phone, we see that every device is provisioned, which is exactly what we want to see. So we'll continue by going to the next step. In this step, we're going to configure and enable our energy meters within the system. We have two meters, the production meter and the consumption meter. We'll start with the production meter. We'll tap on the production meter, which then gives us an immediate reading of the power that's being generated from PV. It says it's about 2.8 kilowatts. The instruction is to make sure that the PV circuit is switched on and has been running for at least 5 minutes. I'll confirm that's the case and tap Next. Now it asks to switch off PV breakers, which I'll do. As we turn off PV, what we would expect is that the generation would drop to 0, which it has. That's verifying that the system is working as it should, so we'll enable the production meter. And now we'll enable and configure the consumption meter. The first pop-up indicates to us that we absolutely must not install consumption CTs on the load side of Enpower. This is to verify that we understand this. We'll confirm by tapping confirm. We're asked, what type of system configuration is this? This is a partial home backup with the consumption CTs placed between the utility service and the main breaker. So that's correct. We'll go ahead and tap next. Now we're displaying the home loads with no PV. This is strictly the loads. It's asking us to switch off PV breakers to verify that we don't have PV turned on. We do not, so I will tap next. The next step asks us to turn on a known load, a higher load, and we want to observe what happens to our meter. We've just now added a fairly large load, and we can see that our load values have gone up. So I will tap that I followed the instruction to turn on a known load and verify that it is going up as it should. My total home load has indeed increased by several hundred watts. So I'll click yes, and I will click next. And now we're instructed to turn on the PV breakers so that we can add energy production into the mix. So currently we're consuming 562 watts. I will turn on the PV breakers, and this should take about a minute for my PV to ramp up in my system. And so I've turned on the timer, and we can see that our loads are now covered with our PV production, which already has been producing. So we are now exporting 2.3 kilowatts and servicing our loads. So I'll click next. Now our net power is exporting to the grid. That's our PV, which is feeding our loads. 2.3 kilowatts is exporting. I'll click next. And now the very last step in this is to enable the consumption meter. Both meters are now configured and done. The Ensemble software update section tells us whether or not the system has all of the prerequisite software to continue for commissioning. When I click into it, it tells us each device and the software and whether or not it's ready for functional validation. In this case it is, and we can continue forward. If any of the system devices need their software updated, the device will show not up to date and will automatically start updating and show you the progress. The updates are required and cannot be skipped. When the updates are complete, the app will read up to date, ready for functional validation. Functional validation is the last step of the commissioning process where we test and verify if the system will work properly in grid-connected and microgrid modes. To begin the functional validation process, tap on Functional Validation, which will bring you to the Live Status screen. Live Status shows near real-time updates of power flow in the system. This system shows about 3 kilowatts of solar being produced, providing 7 watts of charge to the batteries, exporting 2.8 kilowatts to the grid, and supplying about 200 watts of power to feed the home loads. The Installer app will guide us through the functional validation process. All Ensemble devices have to be ready for commissioning. Production and consumption meters must be enabled from the previous commissioning steps, and the batteries must have at least 15% state of charge. If these conditions aren't met, you won't be able to continue. Tap Proceed when you're ready to continue. To run functional testing, there must be active loads running in the backup panel. Click the checkbox to confirm there are active loads, and that Live Status shows batteries are being charged. It may take 20 to 30 seconds to see the power flow status update in the live status screen. We have to be patient. Click Next to continue. The next functional test step is to put the system into microgrid mode. Using the on-off grid toggle switch at the top right of the screen on the app, disconnect the grid. The system will signal the system controller to open the MID contactor to disconnect the system from the grid. You should hear a click when the contactor opens and disconnects the grid. Check the box to confirm you've completed this step, and then tap Next to continue. Live status will show the grid as not connected when the system goes into microgrid mode. Verify that the microgrid is operational and working. PV should still be producing. Backup loads should still be running normally if they're sized properly for the system, and batteries should continue to operate normally. Confirm that the system is operating correctly by tapping the checkbox and then click Next. Next, we're instructed to add additional loads in the backup system and wait for 60 seconds. Add a load that preferably you know the power of. Live status will show the change in power. The power flow in the microgrid should change to meet the need of the loads. Waiting 1 minute allows the system to stabilize and for live status enough time to refresh the display. Tap Next when this step is completed. Now that the system has been tested for proper microgrid operation, we'll reconnect the grid and allow the system to transition to grid-tied mode. Slide the Go On Grid toggle switch at the top of the Installer App screen. Synchronizing the utility grid signal to the microgrid signal could take 5 to 15 minutes. You will hear the MID contactor close as the system goes back on grid. Live status will show power flow when the grid is reconnected. Tap the checkbox and then Next when this step is completed. The last step is to confirm the system transition back on grid. The Installer app will indicate when the functional validation process is complete. Clicking Continue will begin the full system software update process. The official system commissioning is finished and the installer can leave the job site while the software update runs and completes. The system summary report lists all of the hardware installed at the site. It includes configuration details and last known status for each item. The summary report can be used for verification and validation of work on site and shared with operations teams for record keeping.